All right, so let's talk about the first smart contract here, C351. One great thing about the great rise in cryptocurrency prices in 2017 is that it funded people to prepare a lot of training materials for this, and they made the Remix IDE, which is wonderful. So I'll open this in Chrome. The Remix IDE is a simulated blockchain that you can run in your browser, or you can connect to any other blockchain and develop contracts here. So I'm going to move these instructions to the side and demonstrate it live here in my Chrome. All right. So we want to put in a script of faucet. All right. So it is right-click on scripts, contracts rather. There, I've already got it here. So we put in faucet. This is Solidity. Now, Solidity is the language that almost all smart contracts are written in, and it is in fact a very terrible language. It's based on JavaScript, and it has several really huge security flaws. There are better languages, but this is the current standard that almost everything is written in. So here's a faucet, like the faucet you just used to get some test coins on the testnet a while ago. And so what this does is it's going to receive any incoming money with a receive connection. It'll let people fund the faucet. And then if anybody wants it, there's a public function called withdraw that will let you withdraw amounts only up to this total. Now, in cryptocurrency, they use integer arithmetic to keep track of your balance in some ridiculously tiny number, like 10 to the minus 18 ether. And that's what this ridiculous number is. This is, I think, 1 ether. 1 times 10 to the 18. And then, so as long as the withdrawal amount is less than or equal to the limit, it just sends you that money. Transfers to the sender that withdrawal amount. This is the contract. And so when you make a contract, you enter the Solidity here, and then you go to the second tab here, where you can compile it. Now you compile it, and if it's done, then you can go down here and see the compilation details, and you see what it's going to do here. And the interesting thing is the assembly here. This is the assembly language that actually implements your contract, and it's using push and call value and whether something is 0 and then a jump. This is very much like any other assembly code, like x86. That's the assembly code that is the compiled contract, and that is actually stored as bytecode here. These are the hexadecimal values that encode all those opcodes. So this is the actual data that's going to be written onto the Ethereum blockchain when this contract is deployed and run. So that compiles the contract, so it's ready to go. And then you go to the third tab, and you can deploy the contract. But first we have to choose which environment we're going to use. And in this one, I'm going to use that testnet. So we go to injected web 3. And that will connect to my MetaMask here, which is why you did the previous project. You have some actual ether on the fake Rothstein test network. And so I deploy this contract, and that costs some money. So it's going to pop this up and ask me to confirm it. It's about to spend some amount of my Rothstein money. I'll confirm that. And here it goes, creation of faucet pending. And since I'm using a real test net that only mines a new block every 15 seconds or something, it will take a little time. Shouldn't take too long, though. Oh, good. It finished. When it works and mines a block, if your transaction succeeds, you see the green check mark. That means it did successfully send it onto the network. And so that means it will have spent a little bit of my money. Some tiny amount of this has been spent. All right. And now we'll be able to see that contract on the blockchain. So down here I have a deployed contract section, and you see it here. I've now deployed Faucet. The contract itself has an address, and you can copy it here. And you can view it on the Rothstein network. So I'll have to do this 2 copies and pastes. So the Rothstein network Explorer is here, and I can find the contracts here. So if I take my contract address, which is this number starting with 6A2, and I search for that, there should be a record of this, and there it is. There's my contract creation transaction on the blockchain. And now I fund the contract. I need to give it some money. So I go back here to my MetaMask. And now I send some money. And I'm going to put in that contract address that's still in my clipboard, starting with 6A2. And now I can send it some money, like 0.3. And say next. And it's ready to go, and it's going to charge me a gas fee of some tiny amount of Ether. I confirm that. And now it's pending. My balance was 3.89, but it should fall when this passes through. Again, it's going to take 15 or 30 seconds for the transaction to go. Yep, so now it went through, and now I'm down to 3.59. I've spent 0.3 Ether putting it in the contract. And now I can see that if I refresh this page, searching for this contract address. Now I have 2 transactions, a transfer into it of 0.3 Ether. Create the contract and feed 0.3 Ether into it. All right, and now I can withdraw from the faucet. So I go back here, and if I expand my contract here, there is a withdraw button, and I can withdraw some amount here. And I think that's it. I don't need to feed an address or anything in. It will send it directly to the address that made this request. So I hit withdraw, and again I have to confirm, because this will also cost me some Ether for the gas. So I confirm that. And again, it's pending. And again, it should take like 15 seconds to go through. There, it's done. So now, if I go here, there should be 3 transactions. I'm not seeing the third one there, but it should eventually appear. This one succeeded. The withdrawal succeeded, so my account should have gone up a little bit again. Yep, 3.5 to 3.6. So I put in some Ether and I got it back. And oh, that's right. That's an internal transaction. So I have to see that in the lower pane in Etherscan here. Internal transactions should appear here. Refresh perhaps. Yeah, here we are. There's the internal transactions. Here's the 3 contracts. So I had create the contract, transfer into it, and withdraw from it. And there's an internal transaction here too that shows you more information of the 0.1 being withdrawn. And so there's several flags to find there. And I'll stop and let people work for a while. And